Hey guys, and welcome back, and today we're going to be going over relations and functions. A relation is a set of ordered pairs, and it's usually x and y, and in this lesson we're just going to be using the x and y. Two more words you're going to need to know is domain, which is the x values, and that's the input, and then the range is the y values, and that's the output. So a relation has an x, a domain, and a y, a range. Here are some ways that you can represent your relations. You can do it with an equation like y equals x squared minus 1. You can write the same thing with words, so y is 1 less than the square of x. You can use a graph, so this is what y equals x squared minus 1 looks like on the graph. You can use a table like this one right here, or you can just use ordered pairs like this. These are all representing the same relation, they're just represented in different ways. Now let's talk about functions. This table here on the left is not a function. And this is why. The x is the domain or the input, and the y is the output or the range. When you put in an input of 1, you're going to get a 0. When you put in an input of 2, you're going to get a 3. But when you put in an input of 0, you're going to get 0 and or minus 1, and you can't come out with two different outputs. On the left here, we have minus 1, which has an output of 0, and 1 that has an output of 0. But this is still a function because each input has an output. Even though the outputs could be the same thing, they're still different inputs. So this is a function, but what it is not is a one-to-one function. A one-to-one function is a function in which each input has its own output, and each output has its own input. So looking back at these tables, this is not a function because this input has two different outputs, and this is a function which each input has its own output, but each output does not have its own input, because 0 has two inputs. A one-to-one function is a function in which each output has its own input, as well as each input having its own output. This table here is an example of a one-to-one function, because each output has its own input, and each input has its own output. Now here we have two different tests to discover if something is a function, or if it's a one-to-one function, or just not a function at all. If it passes the vertical line test, then it's a function. But if it passes the horizontal line test as well as the vertical line test, it's a one-to-one function. Here we have a graph. This is our y equals x squared minus 1. You'll notice we have a vertical line that we can move across the graph like this. And you'll notice that as we move it across, it intersects the graph at only one point. It never intersects it at more than one point. So it passes the vertical line test. So this is a function. Now here we have a horizontal line on the same graph. You'll notice as we move it around, it does touch the graph in two different spots. If it touches it anywhere in more than one spot, then it does not pass the horizontal line test. So we know that this is a function, but it's not a one-to-one function. Here this red line is a graph, and it passes the vertical line test, and it passes the horizontal line test. So this is a one-to-one function. Now what is function notation? Here's our equation here that we were working with before, y equals x squared minus 1. Function notation is basically the same thing, but instead of having y, we're going to have f, our function, and then x in parentheses. Now that's going to equal x squared minus 1. Here we can put in our value of x, say like 5, and then we're going to make this x into a 5. 5 squared is 25, minus 1 is 24. Now let's quickly do one word problem and then we'll finish this out. Each ticket to a movie costs $8 with a $5 entrance fee. What is the total cost? Well, the total cost is going to be our range. So we're going to do c and then x. So that's our function. Now that's going to equal 8, but each ticket to the movie costs $8, so we're going to have to multiply $8 by the number of tickets that we're going to buy. Now there's a $15 entrance fee, so we're going to have to add $15 to this function. Now here's our function. Now say we're going to buy 3 tickets. So we're going to change this x to 3, and we're going to put that in parentheses because it's not 83, it's 8 times 3, and 8 times 3 is 24. Now we're going to add 15 to that, which is 39. So the total cost would be $39. I hope you learned a lot from this lesson, and good luck.